We will start with marginal analysis and economy. Here is the demand function. It is the price Px per item as a function of x when x is the quantity. The demand function Px is the price per unit when x units are produced or sold. The price per item is a function of the amount of items that are sold or produced. It is a decreasing function. As the number of items increases, the price per item decreases. In this section, we will focus on the seller or manufacturers or producer. We notice that the price of an item is not constant, but a function of several market conditions. The same is true for the cost of producing an item. The producer needs to pay for space, machine, workers, and many other expenses. The cost for the first item is very high. Note that the total cost increases when the number of items increases. It looks that it's better to produce and sell as many items as possible. In reality, this is wrong. The cost per item will decrease to an optimal production level, and then it will increase. For example, if somebody is producing too much, you will need to pay overtime to worker, you will need to buy more machines, and maybe even move to a larger space, and all of that costs money. Definition: the cost function Cx is the cost of producing x items. And as we mentioned before, the cost function Cx is always an increasing function, because it is always cost more to produce x plus 1 items than to produce x items. An optimal production amount is important to keep the cost of each item, or the average cost, as low as possible. And here is the average cost. It is the total cost to produce X item over the number of items. The agenda is to decrease the total cost and the average cost. It's easy to observe that AA is decreasing when CX is decreasing. Definition: the revenue Rx is the product of X, the number of items, times Px, the price of each item when X items are produced or sold. And the profit is the net gain. It is the revenue minus the cost. Let's see the amount of money that gets in if X items are sold. It is XPX. This is the revenue. It's the number of items times the price of each. If we will take away the cost, this is the money that goes out. We will get the net gain, which is the profit. That's why PX, it's the revenue minus the cost, or if you want, the profit. For producing or selling X item is the number of items times the price of each, XPX, minus the total cost to produce all these X items. The agenda of any business is to increase the profit. Example: here's Px, the price per item when X items are sold, 230 minus 0.5x, and here's the cost function Cx, it is the cost to produce X item, and it is given here by x to the power of 2 minus 5x minus 300. Assume that 100 items were manufactured and sold. The total cost is, take the cost function and substitute 100 for the x. We calculate that, and we get that the cost or the total cost to produce 100 items is $9,200. The average cost is the total cost over number of items. In this case, it is 9,200 divided by 100, and we get that the average cost to produce each product is $92. Pay attention, this is only the average. It means that if the cost per item was constant, then it would have been $92 to produce each item. In reality, we usually don't have a constant cost for each one of the products. The total amount of money the producer got from the buyer is the revenue. Let's calculate the revenue. If 100 items were sold, then the revenue is the price per item times number of items. First, we have to find the price per item. It is P100. We substitute 100 for the X in PX and we get $180. To calculate the revenue, we have to take PX and multiply by 100 because 100 items for $180 each were sold. We get that the revenue is $18,000. The producer got $18,000 while $9,200 from it was spent on producing. This was the total cost. So the net income is the difference between the revenue and the cost. It means that the net gain is $8,800. This is the profit. What is the cost to manufacture one extra item? That is the 101st item. The total cost of manufacturing 100 items minus the total cost of manufacturing 100 items. If you take this difference, you will get exactly the cost of manufacturing the 101st item. This is C 101 minus C of 100. You first substitute 101 and then you substitute 100. We already calculated C of 100 and we get $186. This is the exact cost of manufacturing an extra item, which is the 101st item. This is more than twice than the average cost of $92, if you recall. A good guess is that this item should not be produced, and maybe 101 items is above the optimal number of items to be sold. When the cost function is simple as this one, it is easy to get exact answer. But when it is not simple, we can estimate this amount using differentials. Let dx be the difference in the number of items. Compare with the regular differentials when dx is very small and almost zero. Dx must be an integer because it is the difference between number of items. In this case, if we are asking about the extra item, when the extra item is the 101st, then dx is 101 minus 100 because we know the cost of the 100. So dx is 1. But dx cannot be less than 1, and it must be an integer. Everybody agree that I can just divide this difference by 1 and I don't change anything. I only change the philosophy behind it. Because now I will call this one dx and I get c of 100 plus dx minus c of 100 over dx. And if dx would have been approaching 0, this would be the exact derivative of the cost. But because dx is not approaching to 0, this is only approximation to the derivative of the cost at the value where x equals 100. Here is the exact definition of the derivative of cx. And here again, because we don't have the limit, it's only an estimate. Let's calculate c prime at 100. We differentiate the cost function and we substitute x equals 100 and we get $185. This is really not a bad estimate. The exact cost of producing the 101st item was $186 and the approximated cost is $185. In general, we can approximate the cost or the revenue or the profit of additional items using the derivatives of the cost or the revenue or the profit. We call this analysis marginal analysis. Definition: the marginal cost is the derivative of the cost, and we write MC of x. Marginal revenue is the derivative of the revenue, and we write MR of x. Marginal profit is the derivative of the profit, and we write MP of x. In our case, we can write instead of C prime 100, just MC of 100 because this is the marginal cost when x equals 100. And this is the approximated cost for producing the 101st item. Let's now approximate the revenue from the 101st item. We know that the exact amount is the revenue of 101 minus the revenue of 100, but this can be nicely approximated by the marginal revenue when x equals 100. What is the marginal revenue? First, we have to find the revenue, and the revenue is just x, px. And now we have to differentiate that. Now let's substitute x equals 100. And we get that the approximated revenue from the selling of the 101st item is $130. Let's now approximate the profit from this one. And I would like to recall that you shouldn't even produce this one because this is above the optimal production level. The marginal profit at 100 is the derivative of the profit, and we will substitute x equals 100. The profit is Rx minus Cx. Now we are going to differentiate that. We get negative 3x plus 235. We will substitute 100 and we get negative $65. This is a loss. It is a bad deal. We already knew that this manufacturer in those conditions should not produce so many items. The approximated profit from the 101st item is a loss of $65. Let's summarize this example. The approximated revenue from this additional 101st item is $130. The profit is a loss of $65. It means that the optimal number of items for maximal profit should be less than 101, obviously. What is the optimal number of items that will maximize the profit? You can calculate that. The profit is Rx minus Cx. Let's substitute XPX for the revenue. We get that. And Cx, just copy. The function for the profit is negative 1.5x to the power of 2 plus 235x plus 300. To maximize, we need to find critical numbers. We differentiate the profit function. We solve it to 0. And we find out that x is 78 plus 1 over 3. We know that x has to be greater or equals to 0, but we don't know how large x can be, so we are going to look at the shape of the graph by analyzing the first derivative as usual. The derivative is 0 as 78 plus 1 over 3. It is plus between 0 and this number, and it's negative if you take numbers which are more than 78 plus 1 over 3. Pay attention, x has to be an integer. So if this is the shape of the graph, we cannot really attain the absolute max, but we can get closer by picking x to be 78. We can summarize then that the profit is maximal when 78 items are produced.